All right, well, thanks everybody. So this is the second part of the day, but obviously the two parts of the day are intrinsically connected. I'd like to give a very, very brief introduction about WA Array. A lot of you will know a lot about it already, but some of you won't. So I'm just going to give us very, very brief overview here before we let the real geophysicists and the real people in the room actually do some talking. So in the previous talk, we were really looking at mostly the crust, and we speculated on some sort of mineral system type approaches. But from these images, and most of you in this room will know this, that we've got to consider the whole of the lithosphere here, because mineral systems, are connected across the whole of that lithosphere, and there's been a lot of work on this. One of the good examples there is on the right-hand side is the Hoggard model, looking at the big inflection in the LAB, typically mapped at around 170 kilometers, showing that at the surface, 200 kilometers of that boundary mapped to the surface, you pretty much get all of your global lead, zinc, copper sort of systems. So understanding the deep lithosphere is really intrinsic to understanding how mineral systems work. And of course, it's about how do we then integrate that geology across scale. We go out, we map, we do geochronology. Rose has talked about the isotopes, which tell us something a bit deeper. We've got the active seismic, which we looked at earlier, and that tells us about basically down to the bottom of the to the moho. But what can we do then to get even deeper? Well, this really then looking in the realms of passive seismic and MT imaging, the techniques that can get us down to 250, 300 kilometers in the Earth. So basically, off the back of OzLAMP and OzArray GA's sort of national scale programs, we didn't think it was going to develop quick enough for WA, so we developed our own program, WA Array, which is the passive seismic part, and WAMT, which is the magnetotelluric part. So we put in a submission to the Expenditure Review Committee, state government, and they gave us 40 million over 10 years to basically do those programs. Where it's different slightly from GA's model is we want to create 40 kilometre spaced rather than 55 kilometre spaced stations, simply because when you take the average depth of the moho, if those are spaced 40 kilometres apart, when you actually get down to the moho, you're actually producing a seamless image of the moho rather than individual spots where you then have to interpret between the two. So that was really an industry recognised component. They wanted us to do it at that scale. So if that's the case, we end up with 1,500 sites that we've got to deploy at. And so you can't buy 1,500 seismometers and deploy them across the states in one go. So really the program is a rolling program of about 150 to 160 seismometers deployed each year. They sit in the ground, though the passive seismometers anyway sit in the ground and collect data for a year. Has to be that kind of timescale to collect enough sort of passive earthquake functions, and from different directions as well. So they've got to be in the ground pretty much for a year. We pick them up and then we roll them into the next area. If you do that, there's basically 9 phases, 9 areas across the state, 9 phases, if you like. With the MT, the program, I'll come to this a little bit later, but that was funded basically a year later than the passive seismic, so we're in a bit of a catch-up phase there at the moment. But again, it's basically with the MT, we've got about, I think it's about 20 instruments, something like that, which we farm at. So it's contracted out to Mumbarga Geoscience, and they basically roll those 20 magnetotelluric instruments across that area over the year. So they sit in the ground for a few weeks and then they get rolled on. But that's not all we wanted to do. We recognized that most of these sites are going to be pretty difficult to get to. Probably 50% of those 1,500 sites, we're going to have to use a helicopter to get to. And that is a helicopter for clearance, a helicopter for deployment, a helicopter to mid-year service, and a helicopter for collection. So in those areas, we need to use a helicopter 4 times at 4 different times of the year. So we wanted to try and do as much as we can at every site, basically create super sites for every one of these, which is, again, across the entire state, spaced 40 kilometres apart. So, of course, we're doing the passive seismic, and we're not just interested in the deep lithospheric components of that. There are things like site characterisation, engineering geology that we can use that information for, local seismicity, looking at regional and state scale stress regimes with the MT. There's a lot of work that we can put into electrical infrastructure. We don't want to be putting, for example, green energy hub in a site that's hugely conductive, so that when we get electrical storms, we destroy all of the infrastructure. So there's a lot of extra things that we can do. From phase 1, we've also basically collected the regolith, and so from that we're doing regolith geochemistry, basically ultrafine plus, and also we're extracting the heavy minerals from those and characterising those heavy minerals. So that will feed back into Australia's heavy mineral map of the state as well. Now, from this next deployment, we're also doing geothermal heat flow measurements with heat needles, and we're doing hydrogen helium sniffing basically at those sites. But what we will do is we will get some more heat needles and we'll start redeploying those in the first 3 phase areas. So we will use the next 10 years to redeploy some of those and actually catch up. So we will eventually cover the whole of the state. So we did think about doing other things like microgravity and things like that. But again, with the instrumentation and what we would gain from it probably wouldn't be very much. But anyway, the idea is to do as much as we can at once at every site. So in terms of data and products, the passive seismic data, once it's been QC'd and collated and we're all very good with it, that data is released through the AusPass portal. The MT data is released through Magix because it's a lot smaller than the passive seismic data. But all of the products that we produce will be pushed through GeoView and be available in Magix as well. For the passive seismic, we defined at the beginning that we wanted to create 9 standard, if you want to call them tier 1 products. So these are things that we'll do for every phase, for every site, things like depth to MOHO, LAB, velocity structures, VPVS, and things like that. So they will be standard across the entirety of the WA program. Tier 2 are things that we are collaborating on. So these are sort of a bit more bespoke data sets. So we're working with CSIRO and ANU to produce some of those. And then, if you like, our tier 3 products, which are really blue sky stuff, which will come through international, national research sort of initiatives and collaborations. But there will be effectively 9 standard tier 1 products that come out for every site and for every phase of the passive seismic program. We will be producing a variety of MT conductivity models, and then, of course, some of the things like site characterization maps, local seismicity and hazard maps, regolith geochemistry and heavy mineral maps, geothermal heat flow maps, and hydrogen helium analysis and maps and things. They will come sort of in the future as well. So where are we? So collection of the passive seismic work in that red box is complete. So today we're going to be talking about areas 1 and 2 because that's the data that we've processed. We've got models for. Phase 3 is the seismometers that we bought in last month. So we now need to actually collate, process, and create the models from that. Then that will get released next year. And then phase 4 is on the eastern side. That blue boundary isn't quite correct, but it's in that region, and we'll be deploying out there in July. So for phase 1, we didn't really do an event like this for phase 1. It was almost a bit of a soft release, but we'll probably do something like this now every year. Again, phase 1 was just a very small area, tiny little bit of the southwest corner of the Yilgarn. We've actually got something a lot bigger now. including the Eastern Goldfields and the Midwest. So that's why we wanted to do an event like this. And from here on in, every year we will do an event like this, releasing the data. So phase one, the data, the models, report, they're all, and the products that were released. Today is where we release the models and products and the data. In fact, they've probably been up on Magix for a while anyway. Dotted around, it might just be on these tables over here, you can see the draft report. So that's not quite there yet, but by the end of this financial year, probably 1st of July, that will be available on the ebook shop. And then, of course, we've just collected the phase 3 data, which is we're collating, and then spend the next year QCing and processing. So as I say, the MT really started 1 year behind the passive seismic. The idea is, again, to roll it out at the same time, because we don't want to use the helicopter again. We need to use it at the same time, or at least synergize our efforts. So the MT is pretty almost caught up with phase 1. So they've done all of the phase 2 area and caught up quite a bit in phase 1, but that data collection in phase 1 will continue. And then we're currently rolling through the phase 3 area. So the idea is to reduce the cost, is to use the same field logistics to do that. So really from here on in, from phase 4 in, the MT will be deployed alongside the passive seismic. So where are we then? So phase 2, yes, the phase 2 data is coming first, obviously, because that's what we've collected, and that will include a little bit of the phase 1 data. That's being QC'd, processed, and the modelling is complete, and that's going to be released here today. Phase 3 data collection is underway, and that will be released this time next year, along with the passive seismic data. So from next year, we'll have everything will be synchronous. And then probably a little bit into the quarter 3 of this year, we'll have the draft. We'll have a final report for the MT available as well. In terms of the regolith, so we were sort of calling this WA regolith as well. We've basically collected all the samples for phase 1, phase 2, and phase 3. The geochemistry analysis is actually complete for phase 1 and 2. Phase 3 is currently being processed. The heavy mineral mounting and the TEMA analysis is complete for phase 1, and again, it's going to be released here today. I think we've pretty much mounted all of the phase 2 and done all of the TEMA analysis on phase 2. We're still doing a lot of the processing for that though, and then of course phase 3 is going to be underway from here on in, and then the phase 1 report will be coming soon. The reason that sort of the TEMA, the heavy mineral stuff, and is sort of lagged a bit behind is because this is really new. It's not easy to mount that material. It seems logical. You just dump it on a slide, make a mount, and then you're done. But actually, there are different flotation issues, and so we've actually perfected the mounting method for that to make sure that we get everything at the surface. And then, of course, there's a huge amount of work into those TEMA libraries, and we spent, Jen's been spent practically a year trying to develop the TEMA libraries for these really, obscure sort of silicate minerals and all the secondary materials that we actually see in those heavy mineral separates. Now that those libraries are complete, it's almost plug and play from here on in. So we kind of expect that the MT, regolith, heavy minerals, passive seismic from here on in will be released pretty much all on the same day in events like this from here into the future.